Hey everybody, it's Tiffany with the IoT Minute. Today I'm going to answer the question, what in the world are digital twins? For a lot of you, you've probably never heard this term in your life. Digital twin is probably most prevalently used kind of in the industrial IoT side of things when it comes to IoT, the M2M world. And it's basically because it made a lot of sense to create a digital representation of a physical machine, a physical object, in exacting detail in some cases. And this really mostly comes from the industrial world. It's definitely spreading, and I think we're going to start seeing digital twins everywhere. But that's basically that's what it is, a digital representation of a physical object. How do I describe that? If you have a car, you know what a car looks like, your physical object. It's got 4 tires, it's got windshield, it's got windshield wipers, it's got side mirrors, it's got an engine, things like that. Building a digital representation of that car is super helpful in the IoT world, in modeling it and seeing what's going on, what's the current state of all those components of that car. Obviously, I just barely scratched the surface of the components in the car, but digitizing that. So how do you digitize those things? Well, every part of the car that you have sensors for, you can represent those digitally. So what's the tire pressure? What's the RPM on your engine going at? What's the temperature outside? Hundreds, maybe thousands of different data points you can have from those things. And so as the physical object is sending you that information via telemetry into your IoT platform, you move that data into the digital representation, in this case of the car. And then you get the actual values of all those sensors, And so at a base level, that's where you kind of start. And then you go from there. A digital twin can be as, exhaustively big and complex as you want it to be. I kind of just gave you kind of like, I like to think of things in terms of your stereo system, I'm turning the volume to 0, or I'm going to turn it all the way to 10, or maybe 11. And so that's kind of turning it to 1, just getting the sensors. Then you can start adding metadata about your physical object that you want to have digitally. What's the dimensions of the car? When you turn it to 11, and there's companies that totally specialize in digital twins. On the opposite end of things, you could have 3D CAD models of your physical object represented in your digital twin. So it can go as pretty crazy as you want to. At Hitachi, where I build Lumada, we call it something called an asset avatar. Since we're an industrial company, we think of machines and things like that as assets. And we think of the digital representation of that as an avatar. There's also another part to this, though, that I haven't included. We call it an avatar type, but you want to start with some place when you're thinking of digital twins. And so instead of just having the twin of my specific car that I'm talking to you from now, I might want to first have something that defines the twin first, maybe for a class of cars, for instance. So, like, I'm sitting in my Lexus SUV, and it's a Lexus RX 350, and so I would create a type. That's my type of digital twin, and it defines a bunch of properties by default. And it defines all the sensors, all the different subsystems that are our digital twins themselves, all the relationships, everything you want to know about this particular car. We create a type first. If you're a programmer, think of this as a base class that kind of is your starting point. And then the actual digital twin itself, in the case of Lumada, the asset avatar itself of this Lexus is this particular one I'm in. And so it inherits all those properties, all those features, all that metadata, all this information you want to do, rules you may want to execute against different systems, behaviors, things like that. It inherits that from the type, that base class, if you're a programmer. And then you have the instance of this one, so the car I'm in. And so it's getting the live data that it inherits from that base class. It acts on those behaviors, and all the subsystems when different temperatures are changing, different motion, property, all kinds of things, vibrations. And so in the end, you're doing this because You want it to help you maybe predict failure, maybe predict remaining useful life. Not only just this whole car I'm in, but in subsystems of the car. Or if a subsystem has a property of the subsystem, a sensor, a component of a subsystem starts to have a failure, will there be a cascading effect from that subsystem up to this whole car itself that'll cause this car to fail? Or is it no big deal and it can be managed later? Predictive failure analytics, using machine learning is a big deal, as you can imagine these days. And so having that digital twin and being able to represent those things and represent digital twins as subsystems of complex machines is a huge and easy way to tackle this problem and combine it with things like regular analytics and more advanced stuff, machine learning, things like that. It's all good. It's a great starting point. It's also something that a person can wrap their head around. When you get too esoteric with some of this stuff, their eyes glaze over. A digital twin, it's easy to say, hey, on your computer screen, here's a representation of this car. And you can see all the information, its current state, and its history, and how other cars like it are doing, and what it should be like, and what's anomalous. It's a great way to wrap your head around things like that. Anyway, this is just the beginning of a discussion on digital twins. I just wanted to get you started because this is an important topic. So anyway, if you like what you're getting from these IoT minutes, definitely subscribe to my YouTube channel and give me a like. I'm out.